to get started. Welcome again, everyone, to this webinar from the Agroecology-TRANSECT project. You'll hear a little bit more about the project in a second from our coordinator, Bertrand Dumont. But in the meantime, just a reminder, please introduce yourselves in the chat. Use the chat for questions as they arise, as you listen to the presentations. The topic today is boosting farm resilience, intercropping and sustainable pest management. And we're going to hear from the work that we have been doing in our 4-year project, both in Europe from 2 of our innovation hubs, but also in tropical Guadeloupe. So really interesting and rich to hear those perspectives on this topic. And we're hoping also to hear from someone representing Agroecology Europe to talk a little bit about some work and a paper that they have put together and published on the subject or similar. So I won't hold anyone up. I think I've mentioned everything. Also, we will be sending out a poll towards the end of the session. Please do take time to give your feedback and answer that online poll because it really helps us form these sessions. We hold a webinar roughly every couple of months, and we will do towards the end of the project, which falls in at the end of August this year. So please do give us your feedback. It helps us form what we talk about and why. So Bertrand, if you're ready, I hand the floor to you to introduce both the project and what we've done on sustainable pest management so far. Bertrand.
Thank you, Tim. I hope you can see my first slide. So welcome, everyone. I think this is our webinar number 12 from Agroecology-TRANSECT project. I just remind you that TRANSECT means transdisciplinary approaches for systemic, economic, ecological, and climate change transitions. And today we will talk about how to boost farm resilience thanks to some agroecological practices, focusing especially on intercropping and sustainable pest management. And you see that on this first slide that we aim to promote a dialogue between continental Europe with examples from our innovation hubs in the Netherlands and in Slovenia, but also with the tropical world because we are lucky to have 1 out of our 11 innovation hub that is in Guadeloupe in French West Indies. So agroecology in a nutshell, I can go very fast to that because many of you have already attended some of our webinars, but our aim, our ambition is to develop robust evidence on the positive effects of agroecology on 3 dimensions, climate change, both in its mitigation and its adaptation dimension, biodiversity, and farm resilience. And today you will see that we will mainly focus on the last 2 dimensions, biodiversity, both natural biodiversity, but also plant agrobiodiversity and farm resilience. We have a number of stakeholders who we think could be interested by the results of our project, that are farmers, advisors, NGOs, decision makers, and our ambition is to provide all of them with knowledge on the positive impact of farming with nature. And this will be achieved by fostering local co-created knowledge by engaging in 11 real-life situations, and we call these the living labs. We call them innovation hubs. They are represented on this map, and today, as I already mentioned, we will focus on the work that was conducted in 3 of them, Netherlands, Slovenia, and Guadeloupe. I would just like to highlight that in relation to what we will discuss during this webinar, we have already produced some significant results. First, I would like to mention this meta-analysis that was led by Keen Blex, and that was published recently this year in Agriculture, Ecosystem and Environment. In this meta-analysis, we highlighted the benefits of agroecological interventions on biodiversity based on 123 studies. And we observed that agroecological practices enhance biodiversity in annual cropping systems and also in horticulture. The way it is represented in the meta-analysis, as I'm not sure you are familiar with this, is the way you see on the graph. You see that there's a vertical line at 0, and each time we compare in each In all this paper, they compared agroecological interventions with a conventional control, and then we calculate a sort of ratio, and that is expressed by this standardized mean difference. And when you see that the mean and the deviation is above zero, we can conclude from that we have a significant positive effect, in this case, a significant benefit of having an agroecological interventions. What is represented here by the numbers, for instance, for arable crops, 778 is the number of comparisons we could find in 64 papers. And you see that it's significant for arable crops, and that there is a tendency for horticulture, maybe only a tendency, because you see that there are less papers. And if I come back to some of the interventions we will discuss today, you see that it's more difficult to have significant results because also there are less paper focusing on that. But you can see in yellow that flower strips have benefits on wild biodiversity, and also that agroecological service crops in blue can have some benefits. And you will, in Margot's talk, hear again about these flower strips and agroecological service crops. And I would just like also to highlight that you can not only read the paper, but also find more information in a webinar we already had in this series of webinar 1 year ago. And you can find this webinar and our webinars on our YouTube channel. Also, we are co-developing a multi-criteria assessment tool, which lets us to co-develop criteria and indicators related to biodiversity and farm resilience. This is the overall structure of our tool, where we have defined 9 common evaluation criteria based on 50 standardized indicators that are measured in each farms that are being surveyed in our 11 innovation hubs. And you see that a number of these indicators are directly related with what we will discuss today, how to decrease the intensity of pesticides, the number of semi-natural habitats, the crop rotational diversity, and also farm autonomy from commercial inputs. These are some examples. And we are indeed capturing temporal diversity of plant biodiversity through a crop rotational index, and we in monitoring agrobiodiversity at both the field and the farm scales. And it just also information for you that we will have another project webinar in spring 2026 focusing on this multi-criteria assessment tool, in which we will shed more light on the selection of relevant indicators across different innovation contexts, and we will showcase preliminary results on the performance of different agroecological systems and practices for all of the tool's 9 evaluation criteria. But this is for the future. But what do we do today? Today, really, our ambition was to promote this dialogue between the tropical world and continental Europe. That's why many of the processes on sustainable pest management will be introduced by Margot Gumbo, who did a PhD in Guadeloupe. And this is a story on how parasitoid wasps and service plants interact to regulate some cucumber caterpillars. So the butterfly on the blue flower is the enemy, and you will see the strategy that is developed to reduce its impact in a natural way. But we will also have European perspectives, first from Tony Balesta, who was coordinating this policy brief that was produced by Agroecology Europe, and we are welcome always to promote interaction with other initiatives and other projects working in agroecology in Europe. And we will also have the feedback from both Maria van Boxel in the Netherlands and Alexandra Waldman working on intercropping and strip cropping in a European context. You see on the picture at the top, this is the Netherlands, and at the bottom, this is Slovenia. So you see that the strips are not exactly at the same scale, and we will also discuss what it can, which are the consequences. And this discussion will be chaired by Tim Dickens from Soil Association. You already heard. And the final discussion will be moderated by Jean-Marc Blasi from our Innovation Hub in Guadeloupe. And we will also focus on the barriers and the levers to the transition. So thanks a lot. And I give back the floor to the next speaker.
Thanks, Bertrand. I think we're still waiting for Tony to speak about to arrive. So in the meantime, we'll head over to Guadeloupe and Margot to speak about your experiences and your work there around parasitoid wasps. So over to you. The floor is yours, Margot. Thank you.
Thank you. You can see my screen? It's good. Perfect. So hello everyone, my name is Margot Gambo and I'm a postdoctoral researcher at INRAE in Guadeloupe. And today I will speak about my PhD works on the recruitment of parasitoid wasps by service plants for the natural regulation of defoliating caterpillar in cucumber cropping systems. So first, crop insect pests are insects considered pests for crops at a given time and in a given geographical area. Each year, they cause losses of 40% of agricultural production and economic losses exceeding $220 billion. Crop insect pests can cause both direct losses, such as plant disease consumption, or indirect losses, for example, with pathogen transmission. To manage pests, chemical control involves massive use of chemicals, and if this allows an effective short-term yield production, it's often associated with significant environmental and human health risk. So by this way, it's an unsustainable practice. And in opposition, biological control is the natural regulation of pest population through the use of biological control agents, we are also called auxiliaries. And this practice allows a reduction on reliance on chemical inputs with lower environmental and human health impact. So it's a more sustainable practice. So there's three types of biological control, and the first type is classical biological control. We consist on a single release of small number of exotic auxiliaries. So for example, here with the introduction in Guadeloupe of Tamarixia radiata from Asia, generated to control an auxiliary pest, so here the Asian citrus psyllid. The second type of biological control is the augmentative biological control. We consist on regular and massive release of auxiliaries, not necessarily exotic. So for example, here Trichogramma preciosa, to control pests that's not necessarily exotic too. So for example, to regulate Lepidopteran egg. So this consists to take auxiliaries in the environment and then have a rearing platform for the multiplication and then the release in the environment. And finally, the last type of biological control is the conservation biological control, which consists in protection and promotion of naturally occurring auxiliaries population by modifying the environment. So for example, with the addition of hedgerow and flower, and also the modification of the practice of, for example, with the reduction in pesticides and changes in TH practice. So in biological control, auxiliaries are antagonist living organisms used to control crop pest population. It could be predator, pathogen, or parasitoids. 75% of parasitoids belong to the order Hymenoptera, such as it's the same order as bees and ants. So parasitoids as like tiny wasp developing at the expense of another insect called the host, and in biological control it's a pest, and causing its death either directly or indirectly as a result of its development. So parasitoids are the first factor of best demographic control, and by this way, they're really valuable auxiliaries for the pest regulation. At the adult stage, parasitoids rely on plant-derived resources, including food resource, refuge, and alternative host. It's why flowering plants are really important in agro-system for enhance this community. In this context, service plants are plant species that are integrated into an agrosystem in addition to the crop, with the aim of providing one or more ecosystem service. This service plan can act on aerial pathogen, aerial pests, but also soil-borne plants or weeds, and they can have direct mechanism, for example, by the intercropping with a crop and service plan. The service plan can, for example, hide the crop or change the research behavior of the pest, or for example, be also repellent for the pest. So that's the direct mechanism. And service plants can also have indirect mechanism. So for example, here in the concept of conservation biological control, by the attraction of auxiliaries that are gonna then regulate the pest. So integrated flowering plant is really important in agrosystem because it allows the creation of essential habitat for parasitoid. And by this way, service plants as really key component of conservation biological control. So as we've seen, biological control contributes to a reduction in pest population, to increase parasitism rate and host mortality. But 64% of agricultural soil are still affected by pollution. And actually, biological control is currently applied on less than 1% of global agricultural land. So we can ask the question, how can conservation biological control be promoted? So our study takes place in Guadeloupe. It's a tropical island with tropical climate that's really favorable for pests. So we have a real pest management challenge here. And because it's a small island, we have also 80% of the food which is imported. So a real need of food in transition. So we have decided to work on Cucumis sativus, the cucumber, because it's an important local and worldwide crops. And we choose to work on Diaphania yalinata, the defoliating caterpillar, because it's the most genus whose larva feeds on diverse cucurbits, and in Guadeloupe, it's the major pest of cucurbits. We chose to work on conservation biological control and specifically the parasitoid wasp recruitment by service plants, because due to tropical climate, we have in Guadeloupe a high biodiversity level. And Guadeloupean agriculture is characterized by small indigenous exploitation that could be a real opportunity for integrate the innovation of service plants. So for that, we have developed general methodology for designing an agroecology crops management system that effectively integrate biological control with the evaluation of plant species for auxiliaries attraction and the integration of those plant species directly in agrosystem, and also with knowledge on auxiliaries community and auxiliaries associated with the pest. And also designing an agroecological crop management system will remaining compatible with farmer expectation and practice and practical constraints, with ex-ante assessment of farmer interest, especially on planter preference and design preference, and also with an evaluation with farmer on the integration of plant species. So I'd say the first step of the work was to assess farmer interest in the proposed innovation, so service plant integration for parasitoid recruitment, and identify the constraint in opportunity of adoption, and also design the innovation in line with farmer preference. For that, we have realized a survey of 30 market gardeners in Guadeloupe using a semi-structured questionnaire. So the major constraint stated by farmer is the workload increase that was stated by 77% of farmers. And the second one is the lack of knowledge. That's really an important constraint, and that shows that even if farmers are interested by the innovation, they don't really know how to adopt and set up this innovation. So the lack of knowledge is also associated with a major opportunity, which is the access to knowledge and training. And it's really interesting because the second major opportunity stated by farmers was the service plan tree. So the selection we made of service plants is really important for farmers and will really contribute to the adoption of this innovation. So we have also assessed the preference for service plant tray, and in Guadeloupe, farmers really want to have plant that are ease of management, so possibly perennial with no competition for of the crop. So some like this. They're also looking for plants that have profitable traits, so we can provide a supplementary income. They also have mentioned auxiliaries attraction and pest regulation, so that's really interesting. But they spoke a lot about bees, mainly for honey production. They also are interested by ornamental plants and, if possible, multi-service plants. It's better. It's really interesting because in our study we see that there is difference in living interest of farmer about the innovation, with mainly a good level up to 50%. But even if we have difference in interest, all the farmers share the same perception and preferences. So based on this result, we have developed a farmer adapted system design at the service plants level and at the field level. So we have only select plants that are easy to sow and easy to remove, which are perennial, which are local and abundant, and we can provide a supplementary income. So only ornamental landscaping for development of educational farm or medicinal and edible plants. And at the field level, we decide to integrate the plants as a central forest strip because it was the design preferred by farmer. And we have adapted the system to be suited to mechanization and also a system with the reduction of pesticide use. So another important point of this study was to assess the plant attractiveness in terms of parasitoid diversity and abundance. And we have selected 6 plant species that match with farmer acceptation. So Bidens pilosa and Cosmos sulphurus, that are 2 melliferous plants. Canavalia ensiformis, that is a fabaceae and can allow nitrogen fixation. Lipia alba and Portulaca oleracea, 2 medicinal plants. And finally, Ocimum basilicum, an aromatic plant. So we have made 3 pot spade plants species, and then we have sampled parasitoid on each pot 4 times per week over 4 weeks period. And we have replicated this experimentation 4 times, so a lot of 4. And in total, we have collected 1,593 parasitoids belonging 22 taxonomic families. And as you can see on this curve, we have a really representative sampling of the community that is present in our systems. And as you can see with the photography here, we have a high diversity of morphological type parasitoids. About the service plants known, we have a significant difference of the attractiveness of service plants. So that's really interesting because that highlights the fact that all the plants attract not in the same way. So it's really important to evaluate the service plants for know which one are the better one to be integrated in the agrosystems. So we have here Bidens pilosa, identified as the most attractive plant species in terms both of parasitoid abundance, so number of parasitoid, and diversity, so number of taxonomic family. We have then Canavalia ensiformis, Cosmos sulphurus, Lipia alba, and Ocimum basilicum. We have also attractive plants, but less than Bidens pilosa. And finally, we have Portulaca oleracea here, identified as the least attractive plant species with no significant difference with the control. So based on this research, so Bidens pilosa, Cosmos sulphurus, Lipia alba, and Ocimum basilicum to be integrated under the real production condition. And the aim of this experimentation was to assess the spatio-temporal dynamic of parasitoid in a cropping system integrating forest strips, and also evaluate system performance in terms of parasitism rate, crop damage, and yield. So this first evaluation has been conducted at an experimental station where we have created 2 central forest strips with some Lipia patches and then mix of the trios of plants. So the parasitoid was also sampled over 7 weeks within the forest strips and at different distance in the field, so 2 meters, 4.4, and 6.8. We have replicated this experimentation across 2 cropping seasons, and this was interesting because the forest strip created during the first season and was maintained for the second season. So in total, we have collected around 6,000 parasitoids, so 1,000 during the first season and 5,000 during the second one. So we can see that we have a significantly higher parasitoid abundance during the second sampling period, and we can also see that we have an increase in parasitoid abundance over time. So that could suggest that the system have allowed the recruitment of parasitoids and also the establishment of the community. And this system have allowed between the two crop period, the maintenance of parasitoid wasps in the agro-system, and it's why we have more parasitoid during the second period. This could be here more like attraction recruitment system, in here more an establishment and a reproduction of the communities. About the spatial dynamic, we have more parasitoids in the forest strip, so that's also a good point because this highlights the fact that forest strips are really important, and it's not a cucumber and just a system will attract parasitoids. There is really an interest to integrate forest strips. And we have then a good repartition of parasitoids in the field, even if we have less parasitoids in the field than in the forest strips, and no significant difference between the distance, but it's probably because the field is quite small, and it could be interest to replicate this in a larger field. But it's a good point if we have a good representation of parasitoids in the field too. So about the performance of the system, we have a yield that is coherent with the range report for organic farming system in Guadeloupe, so that's a good point. We have 63% of leaves that show defoliation marks. So it's a lot, but it's not real a percentage of defoliation because some leaves just show a little mark of defoliation, so it could be good to assess in other ways defoliation. But we have fewer than one caterpillar by leaf, so it's really a good point because usually there is significant yellow loss when we have more than one caterpillar by leaf. And that's really nice because we have a really high parasitism rate. So we have collected a lot of caterpillar and eggs, and in total we have 33% of parasitism. And here you have, I don't know if you know. Okay, I try to play the video, but I don't know what to do. Sorry. So after the realization of the experimentation on experimentation, we have replicated the experimentation directly on farmer fields, and the aim was to assess the feasibility of the innovation. So we have realized this with 2 farms. So normally was supposed to work with more farmers, but finally that was more complicated that it was supposed, and there are some farmers who just can't set up the experimentation. So we have still work with 2 farmers, and on the farm there was 1 plot with a forest strip and 1 plot with forest strip. And as previously, we have weekly sample parasitoid and assess the performance. So in total, we have collected 3,000 parasitoid belonging 19 taxonomic family with quite similar communities composition as said previously. We had a significant higher number of parasitoid in forest strip, so that's a good point that forest strip attract parasitoid in different environments. And about the performances, we have quite the same defoliation level and parasitism level that we had on experimentation. So this on-farm evaluation allows to confirm the result obtained in experimentation. So that's really a good point too. So in resume, this work highlights the value to develop more agroecological systems, integrating biological control and especially service plans for parasitoid recruitment. Because so first we have seen a real interest by farmer in the innovation, so that's really a good point because the aim of this work is to be adopted by farmers. So if they're interested, it's better. This work allows also to identify a local plant promoting parasitoid recruitment, so that's also a good point. And as we see, there is difference in attraction ability of service plants. So it could be interesting now to develop knowledge on ecological mechanism for parasitoid attraction. That could be a next study. We have also successfully integrated forestry in the system, so that's really a good point. We have something that was perennial and that's matched with farmer acceptation, but we have some difficulty to assess really the effect of forestry, so I could be interested to develop more field integrated forestry to have more evaluation. And finally, with the on-farm experiment, we have confirmed that the system is replicable. So that's really a good point because it could actually be adopted by farmers, and there are no risks for the crops, and the thing is really nice. But we have some difficulty for on-farm experimentation, and we need for stronger farmer involvement. So we have to work on the level that could help to work with farmer and develop farmer experimentation with farmer and a level of induction. And in parallel, we have also developed the first baseline database on parasitoids in Guadeloupe with more than 200 specimens, and also identify 7 parasitoid species that are locally associated with our pest, Daphne, which represent 21% of the total diversity of parasitoid already known for the regulation of this pest. So to conclude, we have designed an innovating system integrating conservation biological control to manage defoliating caterpillar. So we have developed a promising system accounting for farmer expectation and constraints, and also an a priori generic approach would seem transferable to other environments and cropping systems. So even if biological control is really promising, it must be combined with other levels of integrated pest management and agroecology. And all of this must be supported through public policy fostering the agroecological transition. Thank you so much for your attention. And I hope this was really clear.
Thank you, Margot. That was a very clear deep dive into your work there in Guadeloupe. And I can see a colleague has shared a link to the paper in the chat. So if you are interested and you're at home, please do take the time to dive into that to learn more, because time is obviously limited today. And there's already been plenty of questions from Margot, which I think is a good sign, which we'll hold on to and come to at the end, if that's okay. Because now we've heard from some of the science in the project. In a moment, we're going to go to a couple of our innovation hubs in Europe to hear directly from the farmers and practitioners and advisors how they're kind of using integrated pest management. But before we do, I just wanted to welcome a short intervention from Tony Ballesta Camara in Spain. Tony, if you're there, hopefully you can join us and switch on your camera. Tony, hi, how are you doing?
Hello, good afternoon to everyone.
Good afternoon. Tony joins us from Spain, where he works with, I think, particularly horticulture and kind of top fruit and fruit to look at some of these agroecological biocontrols, and was a key part of a recent paper published by Agroecology Europe looking at that. We thought just for 5 minutes, Tony, for you to share us some of your sort of learnings from the field, as it were, that you shared in that paper, please.
Okay, so thank you, Tim. Thank you to everybody for the invitation to be here today. As you said, I am a biologist. I work in the field of biological control, agroecology in general. And I were at FAO with Matteo, with Agroecology Europe, presenting my work in conservation, biological control. I'm trying to enhance the environment to promote the local biodiversity instead of buying the natural enemies of pests. Maybe not instead, it's like a complement, because if you buy and release these natural enemies, if you have, enhance your local biodiversity, you provide a house, you provide a refugee, food, and those things for the natural enemies of pests. I'm going to share, I haven't prepared anything, but I'm going to share just a little bit of an example, you know. Do you see this tomato monoculture?
Yeah, we do. We can see that. Beautiful.
Okay, so this is like an example, no? You usually only see the monoculture of the horticulture, trees like olive oil, oranges, etc. What I'm trying to do is to change this kind of agriculture to see more like this, where you see also the tomato, but it's not a monoculture, it's a polyculture where you find these onions, where you find these pumpkins. And what I do with my clients, you know, I am self-employed, I have farmers, big companies and those things. What we do is like we make a house for the insects, not only the typical insects hotel. We use logs, we help birds as well, and we focus also in the flowers. Flowers is the one of the key aspects to promote natural enemies. Pollen and nectar is a key source of food for these natural enemies. So we try to use flowers in the middle of our horticultural crops. We also add water, for example. We can use ponds, but we can use also small bottles and little things, you know. Here, if you put more, you are gaining a greater impact. But I try to adapt to my clients, you know, feel possibilities and those things, you know, because it's different if you grow food, if you have trees, than if you have horticulture. And even though in nurseries, we are working in nurseries where they breed ornamental plants, so it's kind of different world, no? But sometimes just to put some stones like here, you make a great impacts, for example, for lizards, for snakes, and other natural enemies. A great case of a study is Bedcamp Fruits. This is a big company in Barcelona, Spain. And this is, how do you say, a watermelon field, no? So in this watermelon field, they used to fumigate 4 to 5 times per summer, especially against aphids. You know, aphids are they have a lot of natural enemies. For example, here in Spain, we have chrysopas, syrphids. We have plenty of insects that they eat aphids, but they don't usually appear in our fields, and when they appear, they are usually too late. How can we attract these natural enemies? As I told you before, we can do plenty of things, but in this case of a study, just using Lowlaria maritima, that it's a flower, this white flower around here, planting in the middle of the watermelon plants, doing like we call floral intercropping. Just by doing that, we stop fumigating during the last summer. And that's not the only thing that we achieve, because if we have more flowers, we attract more pollinators, for example, bees or bombus. So we also increase the pollination and the production by 10%. So this is so simple. When you plant the watermelon, you plant the Lobularia maritima, and it's like for just a little bit of effort, we gain a lot of, no? So this is what I wanted to share you, you know. It's not so academical. I'm not at the university right now, you know, I'm self-employed, you know, doing the field thing. And it's like it's true, we need to study, we need to know every relation between the plant and the natural enemies that it attracts, but sometimes in my experience, we just need to do something, and nature is so generous to give us a lot of things. So, that's my thing. I want you to share just that. I have plenty of things to talk if you want, so feel free to ask me anything, and I will be glad to answer. Thank you very much.
Thank you, Tony. Yeah, and thanks so much for joining us. And I think it's really great having those practical observations as well as the science too. And that's something that we try and do in these Horizon Europe projects like Agroecology-TRANSECT, is bring together the science and the more practical findings to kind of have a really strong impact in this transition. And this is a great example of that. And hopefully you can stick around, because I'm going to move on to hear from a couple of our innovation hubs, but then afterwards we'll have questions, and there's already some questions in the chat, so feel free to answer directly.
Can I answer them right now? Because I'm a little bit in a hurry. I don't know if I will be in 30 minutes and those things.
Absolutely. Let's just take one question then. We'll do one quick question I can see, and then I would encourage anyone. I've shared a link to Tony's the paper from Agroecology Europe.
For sure.
I
have LinkedIn, I have Instagram. You can find me like Tony Albiolek. I'm going to write it right here. And if I'm seeing one question, if you let me, Tim.
Please do. Go.
It's really important. Does a flower variety influence the decision to attract a specific insect? For sure. Here, if you add more variety, the better. If we have tubular flowers, we have like big flowers, small flowers. In a small flower, a bombus, this insect cannot enter to a small flower, but a smaller one, it can enter. So each variety of flower attracts a different variety of insects, for sure. And if you put more, the better, And if you study, if you monitor every flower, that's the perfect thing. But if not, just as I told you in the example before, just to adding one thing, it changes a lot. So that's my thing here. I don't know, Tim, if you can tell me another question. If not, I'm okay.
I can't see any more right now, but Bertrand has come up with a supplementary point, but not a question. So, Tony, we'll let you go. Thank you so much for your time. And we'll share, as Anna has said, we'll share your details. And I think you've got a YouTube channel and all sorts of stuff. So we'll share that with everyone in the follow-up email after the presentation.
Thank you, Tim. If I'm here, I will be later at the questions.
Perfect.
Have a nice day.
Right. Thanks for joining. Take care. Bye-bye. Bye-bye.
Bye.
And what a lovely segue then to the practice of, as I said, within this project, we have a network or a group of 11 innovation hubs around Europe and Guadeloupe. And we're lucky to have the kind of coordinators of two of them here, Maria and Alexandra, to speak about some of the practical elements of integrated pest management. And so perhaps should we come to you, Maria, first, to perhaps very briefly introduce your project there in the Netherlands, and talk a bit about strip cropping and your experience of kind of an integrated pest management, and then we'll pass to Alexandra, and then I've got a couple of questions for you after that. So please, over to you.
Sure. Thank you. So hi, everyone. My name is Maria van Boekstel. I'm an agronomist and a farm advisor in the Netherlands. And since Tony was sharing nice pictures, I thought I'd also share a nice picture. So what I work with is a group of farmers in the Netherlands who do strip cropping. And as you can see in this picture, is like literally growing crops in long strips. In the Netherlands, it's arable farms we work with. They are like quite big, so 60 hectares, and some smaller farms, vegetable farmers of 3 hectares. And these strips, they vary in width, like from maybe 3 or usually 6 meters to even 39 meters. And the farmers do like this one, you see here, where he has 8 crops in all interchanging, or they have like duos of crops, like 2 crops together. And also there's some farmers who have flower strips in between. And as to what Tony was saying just now, like just the variety you see as opposed to a single crop or monocrop, like one or even 10 or 20 hectares of only potatoes. This is like the diversity you create to have natural enemies. So that's sort of our innovation hub. And then you have a little bit of a picture.
Thanks, Maria. So shall we pass to Alexandra next then?
Sure.
Just to give us an overview, and then we'll come back and hear a bit more about, I guess, some of the specifics of your experience with pest management and pest control. Alexandra is joining us from Slovenia, but I'll let you describe what you do there for the project.
Thank you, Tim, for the introduction. Now, anybody can see. Do you see what my screen now?
Perfect.
Okay. So also I guess I should move this. What the Slovenian Innovation Hub is slightly different in that we are actually a veggie box scheme. So that is our core business, is to deliver organic food, fruit, vegetable, and also dairy products and so on to customers. But we decided a few years ago that we need to be much more than just a trader, in order to be able to influence. The first idea was on a quality of the produce that we get from our local farmers, and also to be able to support them in some of their practices if they want to go further. So what you see on the lower picture is actually our experimental farm, let's say. So it's about 0.4 hectares that we are operating like the Guadeloupe as a market gardening system, meaning that we have very small beds. So our strips are even narrower than the ones in the Netherlands. But, the whole country is having very, very small farms. So small strips are good, but our beds are 75 centimeters wide, meaning that this is also an approach with much less mechanization, if at all. And that's why you need to be able to step across in order to access the different beds to plant and to weed and so on. So we are doing strips, and we have also included flowers from the beginning, as you can see in the upper picture in the background there. But we have a lot of pests, and we come to that in the next part of the session. So this is just the introduction here. Back to Tim.
Great, thank you, Alexandra. So if I could ask you guys some questions, I've got a couple of questions, just trying to link some of the science we heard from Margot with some of your experience kind of on the ground, as it were, on farm. What's caught your attention from what you've heard of Margot's work? And do you think any of it has potential in your context or in the European context? Maria?
Yeah, so it does. So it was really interesting that Margot was talking about like the importation of natural enemies or augmentative release. Very difficult words for me. Sorry. We do not do that, but we do the conservation biological control. So we have like conventional farms and organic farms, both in our network. And the conservation biological control means you like make the environment more good or better for natural enemies. So on 22 farms, we also did lots and lots of beetle counting. That's to say, I didn't do it, but the researchers from Wageningen University did with our farmers. And it's not scientifically published yet, but it's from Wageningen University, the research from Rick Wenink. So please look it up if he publishes it. It's not done yet, so you get a tiny sneak preview. But for example, we found that like small blue leaf beetles, which is a pest in grain in our systems, for every 50 small blue leaf beetles, we get like 10 natural enemies in the monocropping systems, but 15 natural enemies in like the strip cropping systems. And for example, if we look at aphids, which is like a pest in beans and vegetables, if we have more aphids, we have more natural enemies. And we find that the outbreaks have they don't go as high in the strip cropping systems. So we actually find that in these strips, the mobilization of natural enemies is less difficult, it's easier. And the population of these natural enemies is also higher. And we suppose that it is because of like the distance they have to travel is smaller. So that is like really a distance and an edge effect. And this effect like sort of doubles in the edges. And we also see that like bigger insects increase more in strip cropping systems. And this also increases the bird population, which in our country is nice because we want this biodiversity. And we have found that like the number of crops which you vary in your field does not matter much, but it's the edge effect. So you need to have more edges. So duos of crops also works. It's just like you need to make more variation. So the researchers are thinking that the effect is stronger in conventional farming. And this is probably due to the fact that in organic farming, it's already a more diversified system. We don't know, we haven't published it yet, but that could be an idea. So we think that this strip cropping can give you better pest control because of the overall diversity is higher and the natural enemies have somewhere to live, basically, like the house Tony was talking about and the house Margot was talking about. We do not, like in Guadeloupe, do some host plants, but we do have some farmers who do flower strips in between, which are usually permanent flower strips. And we find that you just get like more insects, more variety, so more insects in all insect groups and more species. So that's nice to find. And of course, there are exceptions. So maybe we can talk about that later, but I don't know if you want to continue or if I should point out the exceptions as well.
I think we might save them because there have been quite a lot of questions, I think, already about the risks and the challenges of introducing more auxiliaries and things like that, which probably coincides with that. But I just, what you were just saying about the flower strips reminds me of on the Agroecology-TRANSECT website, we've got a lovely video with one of your farmers talking about the benefits of this strip cropping. And she says at one point, and above everything else, it's beautiful because they have these flowers. So there's something we often forget when we're talking about the science and the yield is actually the human element and the beauty of biodiversity, growing lots of things together, which I thought I'd throw in. And that film you can see it on our website if you're interested. But because time is quite short, I might come to Alexandra with the same question. If that's okay, and hopefully we'll come back to some of the challenges later. Alexandra, what caught your attention from the presentation from Margot, and where do you see similarities and crossover with your context and market gardens in Slovenia?
I'm fascinated specifically by the success also, because I think in our case, for probably a number of reasons, it would have been nice to have those results at the beginning, before we even tried to start. So we have a market gardening system, and the beauty, as if you just pick up, you may see, so this is our system from the ground, and it is beautiful. We also have, from the beginning, integrated flower strips, from a point of view wanting to sell them, so to have an additional economic benefit from them, plus, of course, the pollination and for pest control. We did have in the first year quite good experience with a mixture of Brussels sprouts and chamomile. So the Brussels sprouts were hidden in the chamomile, and that was good for they prospered quite nicely. So we said, okay, kind of the setup that we had afterwards, it would work. It did not. In our case, we had to, recruitment of farmers, we can talk about that later on also, was a problem. And then B, we had two different kind of problems. The first one, we had a situation where, we chose a seed mixture on the market that would not have local invasive, that had more or less local species and did not have invasive species. For our context in Slovenia, and but that seed mixture, we did it one time it was just sown directly onto the field. In a second location, it was actually seedlings were made. In our case, which you see on the upper picture here, the result was that the seed mixture did not germinate at all, 0. So there was no protection, if you want, or no habitat for anybody else to tackle our pest, which was the flea beetle and also the moth that specifically attacks brassica, so broccoli and the like, and cabbage. In the second circumstance, where the seed mixture was pre-grown, so that we had seedlings, as you can see, it did nicely. In this case, the broccoli didn't come out. So there was, again, one half of the experiment and the other half didn't. This coincided because we had a very early heat wave in this season. So weather really and the timing is of the essence. And in such a volatile climate or local weather conditions that we do have now, it becomes extremely unpredictable what will happen and what will not work, or what will work, in which combination. So we will continue and reapply the experiment this year, probably with seedlings starting earlier for sure, and adding the irrigation as an additional buffer in order to have some basis on which we can then actually start looking at both the parasitoids and the pests and see. Because for generally, if you see the for market gardeners, if you see in those pictures here, the lettuce, or also the cauliflower and the what is it, another type of cabbage, leafy cabbage, green cabbage, is that when you have the defoliation, we cannot sell it. So in our case, the economic losses were for broccoli here 100%, for some 80%, because of the pests that were in this year not controlled. So the results from Guadeloupe are really, really important to us to read, to see how we can adapt. And I have a ton of questions, like to Margot also, starting out with, why did you rotate the pots on the field, for example? Because we had, one flower strip in between, and then that was it, also in terms of workability. And how does a permanent flower strip coincide or hinder crop rotation that we as organic farmers have to have through our system in controlling a specific pest? Because the next year in this strip, I will not have brassica. I will have a different group of crops. So how can I sort of compensate with this? So there's tons of questions and a lot to look into, and it's highly interesting to try again now with those results from Michael.
Great. Yeah, great questions, Alexandra. And perhaps we'll have time to put those as well in the Q&A shortly. I want to know the answer as well for someone that's interested in growing vegetables in rotation. So just before we move on to the Q&A, because I know time is super short, we're running until about 3:30 or until 3:30 Central European time. So I just wanted to ask if there's one thing, because we're kind of really interested in this project about the kind of intersection between the farmer and the practitioner and the science and the research. So Maria and Alexandra, perhaps Maria first, if you have anything, like, what do you need from researchers like Margot or Bertrand or Jean-Marc to actually be able to test these ideas yourself as an advisor or as a farmer on farm? How do we make those connections stronger? Maria, do you have an idea?
Well, it's very interesting to have like these trials, and also that they're done in practice in Guadeloupe. So it's not like just an idea in the laboratory. And we also, of course, work with researchers in the Netherlands, and they sort of help us like design the strip cropping plots. Also, we're just in the stage, I think, that we're looking at what works, and we find that just making more biodiversity in any way already helps. So we're not that specifically looking at very small plots and small beetles. And the augmentative release sort of scares me. So I would not, I think, recommend that to the farmers I work with, or we wouldn't do that. And that comes from the fact that we have like one exception to our rule, which is the Colorado beetle, which eats potatoes, you know. And that, of course, is an exotic species in the Netherlands, so it does not have natural enemies by itself. So we find that if we do strip cropping with potatoes, we get like 75% more Colorado beetles in the potatoes in the strips, and 33% more Colorado beetles in the grains. This, of course, is not very nice for our farmers. Like Alexandra was talking about, sometimes some things fails with us as well. So this is, I think, because it does not have a natural enemy in the Netherlands, and it survives below ground, so it doesn't. It can just live on. We have not yet sort of found the solution to that. And also, I think our government would be very hesitant to do augmentative release. So this is not really a thing we're following. So we find that in potatoes, thank goodness, it's very nice that you have for other pests and diseases. And then in this part, disease control, it works very well against Phytophthora. So a potato fungus, not a beetle, because the fungus can just go in the strip and not in the width of the whole field. So there is a sort of a balance in the natural system you create between the one pest which can increase and the other, like disease which can decrease. And then a farmer has to decide which one in his case or her case is like the most important one. And they can either live with or not. So it's always sort of a balance. So you create more of a, and this is the difficulty with scientific research, because it's so specific and done on very small things. And we have the whole system and outside. So it's always this balance which we are discussing with the farmers. And the science gives us answers to one point, you know. So this is always the discussion with the scientists.
That's clear. And you're balancing, a farmer is balancing a lot of needs in something where they're already a tiny margin, and balancing and enough challenges, as we've already mentioned, around kind of climate and market volatility.
And sometimes market volatility, or even the machines you can use, or the machine width you already have, that you don't have to buy new machines, is more pressing than like the one aphid you're going to destroy by having more surface plants or something.
Exactly. Thanks, Maria. And Alexandra, what do you need to hear from researchers like Margot to help you do more trials on farm and sort of test out ideas that promote this kind of more integrated pest management?
We need to have the outcomes in a language that we can share widely. Because if I, so two things, you know, I mean, in this area in Slovenia, for example, we have maybe some experiences for arable fields, but nothing really on vegetables. So that was for us also a problem to get some local support system here. So stuff like the work of Margot is really important, but it needs to be translated really into key facts, and then you can have more scientific behind, but something that is communicable, so that it really makes knowledge actionable knowledge, so you can actually act on it. That is, I think, for me, the key. The key.
Thanks, Alexandra. And I'm going to use my sort of chair's privilege to throw one more in there, because I was in a very interesting session at Oxford Real Farming Conference in the UK this month, and there was a whole session on this. And probably the big number one thing came out is that the farmers and practitioners need to be compensated. So from a policy level, there needs to be more, which in a way they have been in this project partly, but there needs to be more resource put into compensating farmers to carry out some of these trials on farm to really create that impact and bring about some change, because things are too tight if you're a farmer in pretty much any context around the world. So thank you so much. Yeah, and it's great to hear from you. And you're going to stick around for questions. And it looks like Tony's still here, which is fantastic. At this stage, there's so many questions. I'm going to hand the floor to Jean-Marc in Guadeloupe, who's going to chair this kind of discussion. And he's been, I imagine, scribbling down the questions, and I know answering some online. So I'll hand the floor for the last 15, 20 minutes at a push to Jean-Marc and the panel to have a really interesting, rich discussion based on what we've heard already. Jean-Marc. I think you're on mute, Jean-Marc. We can't hear you.
Sorry. Hello, everybody. Thank you very much for giving me the opportunity to open the debate. So we have seen two very interesting presentations giving a demonstration of the potential of service plants and intercropping to regulate pests in a sustainable way. But I would like to bring the discussion on one important point, that is adoption by farmers. And we have in the chat many questions on this point. So one can say that, sorry, I will, yes, it's better like this. One can see that mixed cropping and intercropping can be effective for regulating pests in a sustainable way, but it is very important to see at which conditions farmers would be able to adopt or not massively this new agroecological practice. So there is many barriers to adoption. Bringing plants into a cropping system for intercropping will bring agronomic complexity to manage different crops. There is also a risk of competition between plants, and it can limit the yield. Also, it can be a risk. There are also technical uncertainties, because in many contexts we lack of references, and farmers can be averse to change without security. There is also questions about operational constraints. When introducing a crop in your field for intercropping, you will have to adapt the rest of the system. So you will need for suitable equipment, and also it can bring additional workload. There is also concern about economic constraints, because the initial costs have to be compensated by savings on inputs, on pesticides, for example, and that can also be in institutional or market constraints because of quality standards, for example, that can push the industry to avoid products coming from intercropping system. And then farmers' attitudes can be also a barrier, because some farmers can be reluctant to change because of risk. Their economic gross margin is so scarce that taking any risk can be dangerous for them. So this is for the barriers, but there can also be many motivations. First, reduction in pesticide use can improve your health, your social image also, and it can make it possible to be in line with regulatory on pesticides. many agronomic benefits for the pests, of course, but also for soil structure, for fertility, for all natural pest control. It can bring also to the farms more autonomy and more resilience, less dependence on inputs. And also it can open new economic opportunities toward eco-labeled production, for example, or to comply with the exigencies of public incentives on environmentally sound practices. And it can also give to you and your farm agroecological consistency and give you pride in being innovators in agroecology, and also peer recognition, and also recognition by the society for using nature-based solutions. And then there is a key role of the collective advisors and to give farmers opportunities to see concretely demonstrations in real conditions. So the experiments that Margot has presented, and also the other one, is very interesting in that sense. So adoption of intercropping is a multifactorial decision that combines a lot of dimensions: agronomic performance, risk perception, economic constraints, social dynamics. And this complex question requires the use of many disciplines, and also more than ever to include farmers in the choice of the service plans, and also in identifying with them what do they need for adopting, for testing. How can we accompany them to experiment without too many risks? So now the floor is open for questions or reactions about these aspects on the two presentations that we have seen.
Jean-Marc, are there any questions that you've seen in the chat to bring? So what we imagined was you might bring some of the questions from the chat and put them to the panel live, and facilitate that discussion if possible. And yes, also, just to say, if there are questions left unanswered, what we sometimes do, because time is tight, we will send everyone who is signed up for webinar. We would do some answer some questions written as well afterwards, which we can send out. But I don't know, Jean-Marc, not to put you on the spot, but if you see any questions you think will be well answered by the panel, please go ahead.
A question from James Ellison that say, additionally, it would be nice to see profit figures and to have economic performance. So it's a very important point. We are actually making some synthesis about these aspects. And in our experiment, the presence of flower strips made it possible to produce some honey on the farm, and it can be a way to compensate for the extra labor. But having this economic balance is very important. So soon we will have more results on this point.
Great. Does anyone else on the panel want to come in on that around, I guess it's I haven't seen the question, but around the economic thing around, economic factors of IPM?
Yeah, I can. So in the Netherlands, we have, of course, cap payments, which is like the payment the European Union gives every farmer because of that he or she is growing crops anyways. So then we have an eco scheme, which the Dutch government provides, and there you can get like points if you do strip cropping. So you do some measures which promote biodiversity, and then you get points. And the interesting thing is you can just do, like, as a farmer, she can do maybe 5 hectares of strip cropping on a total farm of 80 hectares, and then you still get the points for strip cropping. and they apply for an extra payment for your whole farm, for the whole 80 hectares, even if you do it as an experiment on a smaller plot on your bigger farm. So this is sort of an economic incentive for farmers to try out these measures, which our government provides. We do not yet have market incentives where the market pays you a higher price. Just for organic, you get a higher price, but not for like doing strip cropping. So we're still in discussion with the market parties who buy the crops from the farmers.
Yes, in the add elements to these questions, in the second pillar of the CAP, of the Common Agricultural Policy, there is payment for ecological infrastructure, and flower strips can satisfy the requirements for being ecological infrastructure. So it can be a way to valorize economically this practice.
That's really interesting. Thank you. I'm looking, there was a question earlier on in the chat around some of the challenges to introducing these auxiliaries. And Margot, I don't know if you saw that, but I was just wondering if you could speak to that a little bit about the risks and challenges of having some of these auxiliaries present.
Yes, of course. Risk depends on the type of biological control strategy that you use. And for example, with the classical biological control is quite complicated because you integrate an auxiliary that an exotic one. So it's really important to be sure that the auxiliaries is really specific to this pest. And that's a good point with parasitoid, because usually parasitoid wasps are really specialists in one species pest. So that's really good point. But they can have competition with other local auxiliaries and or local insect, for example, for food resource or for alternative hosts. So it's why classical biological control are some project that is very, very long to make. It's around 6 and 7 years of experimental study before the integration of the auxiliaries in the environment. And for augmentative biological control is better because it's local parasitoids, wasp, and local auxiliaries. But we add a lot of specimen in the environment. So even if they're local parasitoids, you can disturb the equilibrium between the species who become really more present in the environment. And finally, for conservation biological control is I think the best way, but it's probably because I work on this. Because you just allow and make the recruitment of parasitoid swabs, so there is not introduction.
Yeah.
But I think for an effective conservation biological control, it could be really interesting to combine with other practice such as augmentative, but with a really good experiment on the side effects of this technique.
Yeah, thanks, Margot. And I've seen Tony's just Tony's come on. I don't know if you heard the question, Tony, but you might be well placed to answer this. It was just around some of the challenges of introducing auxiliaries and parasitic wasps and things like that.
Sure, but I have exit the reunion and now I don't see the questions. Can somebody read it to me?
So the question, it was really, I couldn't find it, but just to summarize what are some of the risks? It sounds brilliant, a great solution to just bring in auxiliaries and parasitic things. But what are some of the risks and challenges involved in that you found? Are there knock-on effects that you might not have thought about?
Well, one of the challenges for sure is that this is a thing that it's not so quickly as fumigating. If you fumigate and if you fumigate with chemical products, the insect dies in 2, 3, 10 days. So if I'm a farmer and I have a problem, I fumigate and I see the results. Working with nature takes time. So doing intercropping, restoring your soil, all those things takes time, and you see the effects in months, even years. So sometimes it's difficult to sell to farmers in this aspect. And other challenge is that those things are cheap, but they are not cheap. For example, if you need Tony as a biologist to go there every 2 weeks to monitor the natural enemies populations, the pest population, and now we have 56% of alive aphids. Now we have the lady beetles. Now we have, making the informs and those things. Those things are also not cheap. They have a lot of hours, so sometimes it's cheaper and to buy 10 liters of acetamiprid and fumigate the crops, because you use it a drone nowadays, or a tractor is easier. So in a short term, it's also cheaper, but sometimes you have problems that you cannot fight with the chemicals. They have resistance. You are trying to do things in ecological. So those two things for me are like the key aspects that the farmers, they need to believe before see the results. Nobody quantifies, or nobody says to farmer that it's okay to promote biodiversity and those things. If the farmer, but for example, in Europe, the PAC and those things, those I don't know how to say in English, those scholarships, no, those funds, when nowadays they are beginning um, to give more money if you have cover crops, if you use biodiversity and those things. So if we promote those things to farmers, maybe they see some, they are happier to do it. And sometimes it's like they need to try to prove, and that's all. And when they try and they see that works better, they become. So for me, those are like the big challenges. I remember one, talking about Europe and those things, and now I remember a question that is like, if this works, why from Europe they continue to permit the pesticides and those things? And I cannot answer that question. For me, I wish herbicides and most of pesticides were gone, but here we are with glyphosate 10 years more. So I don't know.
I think I can answer that question because they make money on it. So
Yeah, Maria, because
right.
they have, yeah, for sure, they have interest, the lobbies and those things.
Yeah. So what we are talking to you about today is not like actually common practice in the Netherlands or Slovenia or Spain. These are like more of the exceptions. For example, in the Netherlands, there's 18,000 arable farmers, and there's about 100 to 200 of them who do this strip cropping thing. So it's a tiny fraction, you should know, right? And also the organic farmers is a very tiny fraction. So we think it works, but it is quite an innovative way to grow crops. It's not the main practice yet. So we should keep that in mind, I think. Yeah.
Here in Spain, it is the same. The
Yes.
example that I told you about this big horticulture company, it's like
Yes.
the most pioneer thing in outdoors. And also in Almeria, in the greenhouse, they are beginning nowadays to do these
Yes.
things because they are seeing that it's really true. But the same with green manure, with cover crops, those things are beginning. I hope in 10, 20 years it's the norm, but now it's a pity.
Yes.
Yeah.
I would like to ask a question to you, Maria, because I remember a very exciting discussion we have with you, where sometimes you call it a Trojan horse strategy. When you
Yes.
talk to farmers, to newcomers, you do not mention agroecology. You
No.
mainly mention soil health, the benefits of economic diversification. So you mainly refer to principles rather than to the term agroecology. And I would like to know if you, and same question for Margot in Guadeloupe, or for Alexandra in Slovenia, when you talk about strip cropping, integrated pest management, are farmers, Dutch farmers in your case, naturally open to that? Or does it sound a little bit weird? And do you use also some types of Trojan horse strategies, or can you talk openly about it?
Yeah, sure. Yes, we do a little bit use it as a Trojan horse strategy, because I usually come from and my main work is conversion to organic agriculture, and this is even more difficult because between organic and conventional agriculture, there's sometimes quite a big divide. If you start discussing strip cropping, even with farmers, even from the perspective of maybe you can lower the use of crop protection and pesticides, because nowadays they're not allowed anymore from the European Union. So farmers see this coming. So they are looking for strategies to reduce the pesticide use. Also from an economic perspective, but also because it's forbidden. And then if you do strip cropping, it sometimes is mathematically impossible to keep a very small number of crops. You have to expand the number of crops. And automatically it is more difficult to plow your fields, because then every time you go 20 centimeters to the side. So you need to be keeping it in a straight line. So you start thinking about soil health or not plowing or doing things differently. And then it is some sort of an introduction into this, maybe more working with nature, without it at the first discussion being like, okay, you're going to convert to organic agriculture or you're going to do things differently, because you can keep the same management in your strip. It's just like you used to do it. So that's easier. And then if they see the results, they can get enthusiastic. Of course, it also looks a little bit more complicated. Even the system the government promotes, where you need to have 5 crops in one field, and then you get paid out from the eco scheme. If you do duo crops, 2 crops, which would be easier to manage and an easier model to get in, you do not get the payment. So there's always a balance. But we use this strategy, maybe you can start with strip cropping, and then we don't mention all the other things. And if you do it, if you start doing with strip cropping, you have to think about the other things. So it can be a good gauge to get in. Yes.
Thanks, Maria. I'm gonna bring us to a bit of a hard stop, because I know we have got to finish at past, but we could carry on discussing all morning or afternoon, depending on the time where you are. We're about, I think, my colleague Balint is about to share a poll, just to ask you. I mentioned at the beginning for participants to let us know how you found it. As I say, that's really helpful to us as we develop the final few webinars in the series. If we piqued your interest, there's all of the recordings of these webinars are available on the Agroecology-TRANSECT YouTube channel and via our website and LinkedIn, and we'll share all the links for those. The next one is going to be in March. It's not completely finalized, but if you keep an eye on our kind of channels, you'll find out when they are going live. And a reminder that with Tony's short paper is available on the Agroecology website, Agroecology Europe website, which we will share a link to. But thank you to the panel, to Margot and Jean-Marc in Guadeloupe, and Carla as well behind the scenes there, and everyone over in Europe and all around the world for joining us. We had over 100 people listening, so it's obviously an interesting topic, and we had some great discussion there at the end too. So thank you all very much for joining us, and I hope I hope you can join us again for our next webinar for Agroecology-TRANSECT. Thanks, everyone.
Thank you, team. And
Thank you.
Bye.
Bye-bye.
Bye.
Cheers. Thank you, Tony, as well. Yeah, thanks.
Thank you, team.